Welcome students to another session with me, Mr. Oscar. And as I said in the last time, we talk about math squared, okay, but not really squared. The 2 stands for two things that I'm very passionate about. Mistakes are allowed to happen, and you can see that stands for maths. Or math ability thrives here. That means maths can only grow and can only flourish if we allow mistakes to happen. And if we don't make mistakes, we are not going to learn why, which is the important thing in maths. If we want to know why something works, we have to experiment. We have to make mistakes. And that is the only way we can make maths fun and relevant. Okay, relevant. What am I talking about there? When we talk about maths, it must not just be that, oh, we did algebra in class. It's what can I do with that math? What can I use it for? How can we make it meaningful in the world? All right, so with that in mind, we are going to talk today about similar triangles. Right, when we talk about triangles, the first thing that comes to mind is a whole bunch of words. Okay, there's a lot of words there, so I would pause there for a while and let you have a look at that. And if you can, maybe write it down, have a look in your maths book or Google it, and see that you understand all those words. Some of it you may have done already in school. Some of it your teachers might still be getting to. So it doesn't hurt to try it out, because if you do, you might actually find out a whole lot more things, all right? But this is the vocabulary that is associated with maths. Another very interesting thing here is trigonometric ratios. That's a whole different area of maths, but it is based on triangles. Okay, so we need to just be aware of all the vocabulary that we are using in maths. Now, the first question I always ask is, why do we need to study these things? Okay. Do you know, for example, measuring distances, navigation at sea, whether trying to find the distance between the planets in the galaxies, that little location finder on WhatsApp and Telegram? All these things are based on similar triangles. Okay? So, we use similar triangles to actually work out distances. That's one of the most important things of it. The second thing is structure. Do you know triangles are probably the most strongest structures that we have? And the reason for that is that 3-prong shape. Because when you have a triangle, you can put a lot of weight on it and it would not break, as opposed to a rectangle or a square. And if you look at buildings, if you see buildings around, going up, new buildings, you'll see all the crisscross of metal, and even the roof. You'll see all the woodwork. Those are all in the shapes of triangles. Again, because it is the strength of the shape. And the last thing that we use, well, maybe there's some other uses as well, but one of the things that we can use similar triangles for is to do what we call scale measurements. If I know the size and the property of a certain object, let's say a small bottle, and if I scale up that bottle to a bigger size, I would not even have to work out what the volume or the area or the surface area is. I can use a scale factor. And that comes from the knowledge, again, of similar triangles. All right, so hopefully you have an idea of why we study this and where we can apply it. Right, now to get into the skills. Similar and congruent figures. We look at congruent polygons, have all sides congruent and all angles congruent. Okay, so there's a funny word that we are throwing out there. I'll come back to that properly just now. Similar polygons. Polygons, many-sided figures, have the same shape. They may or may not have the same size, right? Let's talk about this. Congruent. That word means identical, exactly the same. So I might have 2 objects. They might just be turned on its side or turned upside down, but if I put them together, they should be exactly the same. That is what we talk about, congruent. So that's one of the words that you will have to use in maths, and it has a specific meaning. Okay? Similar polygons have the same shape, not the same size. All right, so that sounds fairly okay. Let's have a look at a few examples. There we have 2 balls. They look the same size, the same shape, so they are similar. They have the same shape. Congruent, they are identical. So let's have a look at these triangles. They have the same shape, so they are similar. They are not the same size, so that means they are not congruent. All right? Hopefully that's fairly straightforward. Another example. Let's look at those two triangles. Different shape, right? Different size, so they're not similar and not congruent. Okay? They are both triangles. Fair enough. Okay. So two figures can be similar but not congruent. All right? Let's using the word specifically. So if they are similar, they have the same shape. If they have the same size as well, then they can be congruent. I cannot say if I have, they can't be congruent but not similar. If they are congruent, then they will have to be similar. Okay? If they are similar, they're not necessarily congruent because the size could be different. So there's a difference between the two types of shapes. All right. Just to finish off on congruent figures so that we understand the difference. When two figures are congruent, they have the same shape and size. So we talk about the corresponding angles. Okay, this is another word that we need to go through just now again. Corresponding sides equal. And we use this symbol, 3. You know, it's like a double equal sign. It's equal, equal. It's more equal than equal. It's so big in its equal that it's identical. And that is what that sign stands for. It is exactly identical. So whenever you see congruent, think exactly the same. Okay? Corresponding sides and corresponding angles means exactly the same side on the two objects, exactly the same angle on the two objects. So we are talking about two different objects that look exactly the same. All right, so let's come to what we're studying today. Ratios, similar figures. Similar figures have corresponding sides and corresponding angles located in the same place on both figures. And the corresponding sides have to have the same ratios. Now, this is something that needs a little bit more explanation. If we look at these two figures, two rectangles, ABCD and EFGH, you can see A would be equal to E. All right, so I'm looking at the two objects, the same angles, so we call those corresponding angles. So A and E, B and F, D and H, D and H on the same side, and C and G. These are corresponding on the same position, the same angle. And if we look at the sides, AB is the same as EF. Not identical, it's corresponding, which means I am looking at the same side of the object, okay? And similarly with those figures there. Right. Let's look at an example. So if I have two rectangles, we say these two rectangles are similar if the ratios are equal. Let's explain the story about ratios. Ratios, as we know, is what? It's a fraction. And we want those fractions to be equal. So they are similar because the ratios are equal. Now, this is what I'm going to show you. So let's look at this. 7 over 3. So I'm looking at that side over that side. I must do the same with the second figure, 14 over 6. And you can see that 14 over 6, if I cancel out 2, I'm going to get 7 over 3. So they are equal. So that ratio, 7 over 3, is the same as 14 over 6. I can look at a different ratio, 3 over 7. So if I look at the short side over the long side, and again, 6 over 14, that is the same. Again, 7 over 14. So this is another way of looking at it. If I am looking at the long side, over the long side, 7 over 14 is a half. Then I need to look at 3 over 6. And that is also a half. So these ratios are all equal. So if I look at two objects, and however I compare them, side over side, or this side over that side, this side over that side, any which way, and if I get the same answers, then it means those figures are similar. Now, there is another case which I just want to illustrate. Can I draw? Okay. If I have a rectangle, and let's say this side is 3 and this side is 5, and I have another rectangle, and this side is 2 and this side is 6. These two objects look similar, right? Because they are both rectangles. So all the angles are the same. The shape is the same. So we would say this is similar. But in maths, we have a very specific condition. That condition is the ratios must be equal. So if I take this ratio, 3/5, and that is equal to 0.6, and if I take this, 2/6, and that is equal to 1/3, so that's about 0.33, you can see that these two are not equal. So although they look similar, they have the same shape and the same angles, the ratios are not equal, which means these are not similar objects. All right? So for similar objects to have any meaning, two conditions. The shape and the angles must be the same, and the ratios must be equal. All right, so those are the key things for similar properties. Let's talk about proportion. What is proportion? This is one of the problems even at grade 7 level. If you ask people, what is proportion, what is rate, and what is ratio, everyone gets confused as to those definitions, okay? The proportion is basically an equation of ratios. All right, so if I have two ratios, I can then quite easily work out what I don't have, all right? And you can see in this case, n is equal to 5 and m is equal to 4. So proportion is taking ratios and making them equal, okay? And this is what similar figures do for us. You can use proportion to figure out the unknown side. And this is where similar triangles actually have so much of power. All right, so proportion and similar figures. So we can use proportion to work out the unknown side. If we look at these two figures, they are the same shape, okay? And if they tell us that these two are similar, then I can make the assumption that the proportions are equal. Okay, so using that, I can work out what n would be. So 10/16, 5/n, and I can work out n is equal to 8. So one of the uses of similarity is to work out the lengths of unknown sides of another object, okay, of similar objects. Let's look at similar triangles now, okay. So they have the same shape, and if we have two similar triangles, the corresponding angles, that means the angles in both triangles are going to be equal. And also, the length of the corresponding sides have the same ratio. So let's have a look at how that works. Let's say I have two triangles, and they are similar. That means the angles in both triangles should be equal. So if this is 25, and that's 65, so that should be 65. And the sum of angles for a triangle we know is 180 degrees. So that's got to be 90 degrees. Okay, so we can work that out. And if we need to work out what is the side of this triangle, we can use corresponding ratios. So 12/4 is equal to 2 over something. So that must be equal to 6. Okay, so we have the fact that we have similarity, we can see that the angles are equal, and we can use that to work out other sides for the object. Now, a couple of things that we have to go through, which is skills on triangles, and this is just to have the skill to be able to do other things. And sometimes in life you have to do things you don't like, okay, but it's necessary. And once you've gone through it, it makes other parts easier. All right, so when we talk about, again, similar triangles, the corresponding angles are congruent. Here's this word again, which means the corresponding angles are equal. The corresponding sides are proportional. Okay, so when we're talking about proportional, let's see how we do this, all right? There's so many things there, we don't need to go through all of it. What we need to do is just remember a few things. If I have two triangles, if I can show that two angles are equal, then the triangles are similar. All right, so that's one of the facts of triangles. I don't need to worry about the third angle, simply because we know that 180 degrees minus the other two angles is going to give me the third angle. So if I know two angles in a triangle, the third one is obvious. Okay? So the first rule is that if I have two angles that are the same, then two triangles are similar. The second rule is sides. We call it side, side, side. Now, if you have done congruency already, then you would know there's 3 or 4 rules in congruency. Side, angle, side, 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 angle, angle, side, and right angle, hypotenuse, side. So those are the rules that we use in congruency. We actually use the same rules for similarity. So when we talk about side, side, side in similar triangles, we are talking about the proportions. So if I look at the longest side, which is 21, and I look at the longest side, which is 14, so 21 over 14 is 3 over 2. Okay? Take the shortest side, which is 12. The shortest side is 8. So 12 over 8 is 3 over 2. And then just to check, 18 over 12. That also gives me 3 over 2. Can we see that these ratios are all the same? And if that is the case, then these two triangles are similar. So if you have a problem and your teacher asks you, show me that the two triangles are similar, that is all I've got to show. I've got to show that the sides are in proportion and the ratios give me the same answer. All right? So that is like a theorem that we can use. All right. Another way of stating that is we say AB over DE, same side, is equal to AC over DF, again same sides, is equal to BC over EF. Whenever we compare sides in similarity, it must be the same sides we are looking at both objects. Okay, that is very important, the order in which we write that. All right, so if two sides, there's another theorem, if two sides are proportional and the angle between them is equal, then that is also tells me that those two triangles are similar. So there's another theorem, side, angle, side. You would recognize this also in congruency. So there's a proper way of writing it, the mathematical way if you like. If an angle of one triangle is congruent to another angle, meaning they are equal, and the two sides are in proportion, then the triangles are similar. Meaning AB, again, over DE is equal to AC over EF. And this angle is what we call included. That angle must be in the two sides that we know. So it's an included angle. So we have side, angle, side. That's why we write it like that, with the angle in the middle of it. Okay? So if I have two sides that are in proportion, and I have the angle that is equal, then those two triangles are similar. Okay? So you will see a lot of problems asking you that type of question. We don't do the proof, but to give you an idea, if I have to prove that these two triangles are similar, if that angle is the same, I could take this triangle and place it into that bigger triangle. And you would find that these two lines are parallel. That is a fact from geometry. If you take any triangle and you cut off the same distances, you will find that the third side is going to be parallel. All right? We don't do it in the course, but it's something that you can look at. So using that, we can actually go through and prove all these theorems. Okay, just to go through a few examples very quickly. If I have two triangles like this, can I say that ADE and ABC are similar? Yes, I can. Why? Because if I look at A is in both triangles, and D and B are equal. So I have two equal angles in both triangles, so I have angle, angle. And that means they are similar. Okay? Now, very important is how we write this, A, B, C. So I start from A, B, C. The second triangle must have the same order. So that angle A corresponds to angle A in the first triangle. Angle B and D are the same, so this one will have D where B is. Okay? And C and E is the third point. So we write these in the exact order that they are equal. Angle A is equal to angle A, angle B equal to angle D, and C equal to E. That is very, very critical when we are looking at solving these problems. Let's have a look at this problem. can we say these two triangles are similar? If I look at triangle CA, if that is the length of CA, which is 9, 6 plus 3, and that is 6, so 6 over 9 is 2/3. If I look at C and E, which is 10 over CB, which is 15, so 10 over 15 is also 2/3. That means these two sides are in proportion, all right? And C is a common angle, so we have side, angle, side. And I can say, therefore, that these two triangles are similar. Again, angle C, common side. Angle D and angle A are equal. Angle E and angle B are equal. So we write it in that way. Okay, and there again you will see I put the reason down. S, side, angle, side. So when you answer your question, always give the reason as to why this is true. Okay, just another example again. How would we write these two triangles if they are congruent? First of all, if I look at the small triangle, LK is 3, KO is 6, so that's half. That's 5, that's 10, that looks like half. That's 6, and this long side is 6 plus 6, which is 12. So that also looks like the ratio would be half. So how do we write this down? K, L, M. So K to L, the shortest side. Shortest side here would be K to O. L to M is 5, so this one is going to be 10, which is O to N. So that is the order in writing our triangles down. All right, the last example we will look at is this figure here. And we can see there are two triangles here. First of all, it looks like a kite, but there are two triangles. So what we need to do is find out which are the corresponding sides. So if I look at the big triangle, 30, 36, and 24, 24 is the smallest side. If I look at the small triangle, it's 16. So 16 over 24 would be my small ratios. The biggest ratio will be 24 over 36. And we'll find that those ratios are actually equal. So looking at that, we can then see that side, side, side is the reason for similarity in this triangle. I hope that gives you an idea of similar triangles, how we can actually identify them, and how we can use the theorems to state which two triangles are similar. Thank you.